Good afternoon, everyone, and welcome to Science Cafe KL September edition. Today we have a speaker from University of Malaya that will speak about the safety and the concerns about nanotechnology. But before that, for those of you who just tune in with us to Science Cafe is a casual interactive session where we have live audiences engage with real scientists to share about science that is relevant to our daily life. So today, I think a lot of us are hearing about a lot of applications of nanotechnology. We have nano material used in our clothing to nano material used for our cosmetics and things like that for easy absorption. So what is the big deal about nanotechnology? And today we have our speaker today, which is Dr. Liu Bei-fen. And for those of you who have not read her bio, she is a senior lecturer and research fellow at Nanotechnology and Catalysis Research Center, NanoCat, in University of Malaya. Her research focuses on the effects of physiochemical properties of engineered nanomaterial, or in short, we call it ENMs, and on their stability as well as their toxicity with in vivo or in vitro models. So basically it's to test the effect of nanomaterials on human beings or living beings. Many of her peer-reviewed papers on the topic includes nanomaterial synthesis and characterization, nanotoxicology, biosensors, and so on. All these have been published in high-impact journals. Moreover, her first authored paper, The Stability of Silver Nanoparticles in the Model of Pulmonary Suffocance, has been published in the ESNT and noted as a science highlight in the UK Diamond Light Source Annual Report. Dr. Leo serves as a technical committee for the ISO standards and OECD certification for products containing nanomaterial in the OECD EHS, which is Environmental Health Safety Program. Moreover, she is a IKM technical committee member for ISO TC 229 working group on health, safety, and the environment relevant to nanotechnologies. Her research group had established collaboration between MIMOS, Imperial College London, top-class research group in the National Heart and Lung National Institute, and the Leeds University in the UK, the toxicology group from New Jersey, US, and also the Diamond Light Source at Oxfordshire. All right, I hope I got that pronunciation correct. Now, I've already introduced the speaker, and I also would like to invite everybody to participate in our survey, which is on slido.com. The event code is SafeNano. This is very important because we wanted to know who is the audience that are joining us with us today, and I know there's 14 viewers out there who is now with us. So if you can just open your web browser, type in slido.com, and put in the event code SafeNano, you'll be brought to a survey link to answer a few questions about who you are and what you understand about today's topic, because this would be very useful for our speaker to understand you and to hone the topic more towards what your understanding of the topic. So before I invite, let me just go to the next poll. Of course, the poll will be available always. So if you're seeing the poll right now, please let us know what do you understand about today's topic right now. And this is just to understand whether or not the session has somewhat improved your understanding of nanotechnology, nanomaterial, and its safety. Now, without further ado, I will just pull out the speaker. So with that, let us invite our speaker, Dr. Leo. Dr. Leo?
Hi, thank you, Sean, for your introductions.
And Dr. Leo, I leave it and I'll pass the floor to you.
Yeah, thank you, Sean. Let me share the screen first. Hi, Sean, can you see the screen?
Yes, I can see it clearly.
Hi, good afternoon all. I'm Leo Daven. You can call me Leo from Faculty of Medicine, University of Malaya. So first of all, I would like to thank YSN Science Cafe, Young Scientist Network Science Cafe, Science Cafe KL, and Paper and Toss for organizing this webinar sharing session. Yeah. So thank you all for spending your precious Sunday with me. And I hope after this webinar, then you have better understanding about nanomaterials and what is their safety concern. Yeah. So during this webinar, I would like to share with you all the introduction of nanomaterials. What is nano? What is the application in different kind of the consumer products? What's so special about nanomaterials? And what is the negative impact, if yes, for the environment and human health? Then after you have better understanding about the nanomaterials, then I will proceed further with a nano safety aspect. So for example, if nano is toxic, so what is the main mechanism why it is toxic? And the life cycle of a product. So for the consumer product, are these products regulated, or what is a risk assessment? Any risk assessment have been done? So that's the questions I would like to share with you all. So please take this webinar as a discussion session. Feel free to ask any questions or give us your feedback after the presentations. So first of all, what is nano? So how small is nano? Can we see this nano using our naked eye? So this is the questions. So in the International System of Unit ISU, 1 nanometer is 1 billion times smaller than a meter. So if I pull out this ruler, 1 meter is equal to 100 centimeters. So 1 nanometer is 1 billion times smaller than a meter. If it is so difficult for you to imagine, so maybe you can take this as an example. If a nanoparticles was the size of a football, so a virus would be a size of a person, or a donut would be as big as the whole New Zealand. Can you get the picture? Or I put it into a simple word. For example, if a materials categorized as a nanomaterials, at least one dimension of a material. For example, if it is nanoparticles, nanotube or nanowire, one of the dimension should be in the size between 1 nanometers to 100 nanometers. So for example, now everyone know about the coronavirus because of COVID pandemic. So coronavirus is around 100 nanometers. It's in the range of nanometer scale. So we can't see it. Even it is around us, but we can't see the virus because it is in the nanometer scales. And the DNA, around 10 nanometers, molecule 1 nanometers. So imagine if our human hair is around 100 micrometers, is in the micrometer scale. One of our human hair, 1 nanometers will be 10,000 times smaller than one of our hair. So you can imagine it is very small and we can't see it using our naked eyes. So since we can't see this nanoscale object with our naked eyes, but they are still much bigger compared to the individual atoms or the X-ray. They are in the angstrom size. I hope you understand what is nano. So maybe next one I would like to share with you all. How can we get the consumer product that containing the nanomaterials in, like for example, in our living rooms? So maybe you can have a guess. What kind of product containing nanomaterials in this picture? First, maybe, The first, for example, the mountain jacket and waterproof tablecloth can be coated using the silica nanoparticles to make them more water resistant. And besides the jacket, the computers are nowadays more lighter, use less power. Thanks to the nanotechnology, then we can bring the computer around, and also our handphone. become lighter because of the size of the nanotechnology made in the transistor in the circuit board. So the computer are faster, more file can be stored, and it is portable. So the next one will be the paint and the coating for the wall. So these paint and coating have nanomaterials, make them easier to clean, harder to scratch, and making the coating last longer. Yep. So what else? The next one will be the badminton racket or the tennis racket. So for example, the badminton racket and tennis racket can be made with nanomaterials, for example, graphene or carbon nanotube. These can make them lighter, more resistant. Yep. So the next one may be the printer. So the printer, the cartridge, have nanomaterials to make them easier to clean and to make them, for example, the size of a pigment that we can tune the size so the color can be changed as well. So the TV screen, as I mentioned just now, same as the handphone and the computers. Yeah, so with the nanomaterials, it can make them lighter, portables, and also like easy to clean for this one. So another one will be the bicycle tire. So it can be mixed. The tire, the rubber can be mixed using the carbon nanotube or the silicon nanoparticles, make them more strength. Yeah. So beside all these consumer product in our living room, what else next? So for example, this is the iron oxide nanoparticle. This is a magnetic nanoparticles that is our collaboration project with Hatalega Group. Another one is a frying pan. Do you know that it contains the zirconia coating that make them more resistant to the corrosions? And the Samsung currently produce the continuous layer of graphene built flexible screen. This is a 63 centimeter large TV. And another one will be the sunscreen. So why we use the sunscreen is to protect our skin from the UV radiations. So by mixing out with a zinc oxide or titanium nanoparticle, it can reduce the opaqueness of a sunscreen component and enhance the UV blocking efficacy. Yep. So another one, a lot of people ask me about the self-cleaning glasses. So these self-cleaning glasses are containing the titanium nanoparticles. So titanium function as a UV filter, so it can break down the organic dirt, so make this glass super hydrophilic. Yeah, super hydrophilic. So this glass is without the titanium coating. This is with a titanium coating. Yeah, so you can see the glass normally is super hydrophobic. Yeah, it's hydrophobic. So with a titanium coating, make them super hydrophobic. So it's just like the self-cleaning applications. So since I have introduced like all the consumer product that containing the nanoparticles, so maybe the next question you will ask is, why nano is so special? So I made the title here, why nano? Yeah, imagine if this is a paper. Yeah, a paper have 6 surface area, 1, 2, 3, 4, 5, 6. So what happens if I peel the paper and make it into the small pieces? Yeah, then I can create more surface. So it's just like the block. This block contains 6 surface. So if I imagine that each length is 4 times 4 times 6 surface, so the total surface area is 96. Yeah. So what happens if we cut this block into the smaller sections? Yeah. So I create the higher surface area. Instead of 4 times 4 times 6 just now, I create more surface area. What happens if I section this into much more smaller cube? So I keep on increasing the surface area. So the volume is the same. So we increase the surface to volume ratio. So it just same as the nanomaterials. The nanomaterials is different from their bulk metals. It's because the nanomaterials have higher surface area compared to their bulk metal. Yeah, and Besides that, and you can see from these figures, nanomaterials, by decreasing the size of the particles, there are more atoms or more molecules on the surface. Yeah, so in the reactions, nanoparticle can react more quickly compared to the larger size of the particles. Yeah, so at this such small size scale, the properties of the materials is very different from their bulk analog. Yeah, so this explains why so many applications using nanomaterials. So according to the nanotechnology market outlook, so the consumer product containing nanomaterial increased tremendously to 1628 in 2013 and predicted to reach 75.8 billion by 2020. So according to the Global Nanotechnology Market Report, the global market is expected to reach 2.29 billion. Yeah, so you can see how big the market is. And among all these nanomaterials, silver is the mostly used nanomaterials nowadays. So maybe you will ask, where can I find the silver nanoparticle in our consumer products? Yeah. So for example, if you go to the shopping center, you might see the Samsung fridge or the aircon that claim that silver ion silver nanoparticles, and also the wound dressing, filter, water purifier, and toothpaste that contain the silver nanoparticles. Yeah, and maybe you heard about the case of Paul Harrison's. So if you see the images, Paul Harrison's skin turned to blue color, and people call him Papa Smurf. That's because of a blue color skin. After he consumed the silver colored water for more than 10 years to treat the dermatitis on his face. Yeah, so now the next question is, since there are a lot of the consumer product containing the nanoparticles, what happens if whether this nanoparticle can be uptake by our human body. So here I summarize the portal of entry of nanomaterials. So how this nanomaterial can be uptake by our human body? There are four main exposure media. First is the depositions. For example, if you put the sunscreen that contain the nanoparticles, zinc oxide or titanium nanoparticles, so it can deposit onto our skin. Yeah. The second one is injections. So for example, if you inject the nano drop, so it will go to our blood circulations. What happens if we use all these nanomaterials and exposed to the environment? So what happens if we inhale it? Yeah, so this will be the inhalation pathway. And fourth one will be the injection. For example, the Paul Harrison incident, by drinking or congest the food containing nanoparticles. So they will uptake by a GI tract. So all these will go through the blood circulations, deposit onto the bone marrow, kidney, spleen, heart, and liver. And some of them may excrete by the sweat, urine, breast milk, and feces. So among all these pathways, the inhalations is a major pathway. So imagine, I'm not sure whether you all heard about the asbestos cases. The asbestos containing the ceiling tiles or the floor tiles at home, if it is undamaged, intact surface, so it will not release the asbestos fiber. So what happens if this asbestos ceiling tile is broken? Yeah, so the fiber can be released into the air. So what happens if we inhale it? According to a research reporter that if the particle is in micron size, so if we cough, it can be removed by the mucociliary escalator. We will remove the particle by coughing. But if a particle is smaller than 1 micron, is in the nanometer size, so it might go deeper into the alveolar regions. So in the alveolar regions, the nanoparticle will first contact with a lung surfactants. So then they will interact with macrophage cells. The macrophages are most efficient in remove the particle in between 1 to 3 micrometers. So if particles are less than 1 micron, they cannot be removed by the macrophages, so they might interact with our lung epithelial cells or go translocate to the blood circulation system. Yeah. So I would like to show some of our study to you all. This is done by our colleague. So we are using the 50 nanometer silver nanoparticles and in the macrophage cell, we would like to see what is the interactions. So in 1 hour, you can see that the macrophages tend to engulf the silver nanoparticles. So in 1 day, 24 hours, some of them manage to uptake enter the cells. So 7 days, in 1 week time, some of the nanoparticle manage to enter into the nucleus of the cells, and we also observe that some of the cells already dead due to the silver nanoparticles. Yeah, so this study done using the 50 nanometer silver nanoparticles. So in our study, we also compare with different size of nanoparticles, 20 nanometers, 50 nanometers, and 110 nanometers. And we found that smaller size of nanoparticles, it is more toxic compared to 50 nanometer and 110 nanometers. Yeah, so as a material scientist, we can design the nanomaterials using, like for example, different shape. We can make it into rod shape, spheral shape, triangle shape, or even we can change their surface, make it hydrophilic, make them like water, or hydrophobic, dislike water, or we can change their surface charge, positive charge or negative charge, or we can change the functional group on their surface to bind with different kind of antibody at optimal for the biosensor, for example, applications. So we even can change the size. For example, in nanometers, it's between 1 nanometers to 100 nanometers, so we can synthesize the nanomaterials with different sizes. Besides that, we also can develop new hybrid materials, for example, conjugate with the DNA, the proteins, and make them in the hydrogel form for specific applications. Yeah, and I would like to show some of the nanomaterials that we develop in our lab. For example, the materials in the nanostar shape, nano urchin shape, cold shell nanoparticles, the nanoparticles or the nanowires, nanotubes in different sizes and different length can be synthesized. Yeah. So I would like to share with you a report reported by the toxicological sciences. So this report reported that different physical chemical properties of the particles will affect their toxicology profile. For example, first one, size. By decreasing the particle size, so the nanoparticle is more toxic. Why? Because it tends to dissolve and form the ions. Yeah, and we also compare like the charges, positive and negative charges. The positive charge is more toxic compared to the negative charge, is because they have better interactions. They can interact better with the cells compared to the negative charge. Another one is surface coating. Our group also compare like PVP and citrate, different coating on the nanoparticles, and we found that with different coating, we will cause a different toxicity profile. Another one is compositions. Yeah, we compare like gold, silver, zinc oxide, and titanium nanoparticle, and we would like to see which one is more toxic. So can you have a guess which one is more toxic if we compare zinc oxide, titanium, silver, and gold nanoparticles? Maybe you can comment in the text box and let us know. If you think zinc oxide is more toxic, maybe you can type Z, silver, and there will be A. Yeah, gold will be G. Yeah. Have a guess which one is more toxic. Yeah. So in our study, and we shows that the zinc oxide is more toxic compared to the titanium and silver nanoparticle and gold. It's because zinc oxide have a faster dissolution rate compared to the other three nanomaterials. Yeah, and the morphology, for example, just now I show particle size, the spherical shape, the nanorod, and the nanotubes. Yeah, with a different shape, you also will change the toxicity profile. And the rod or fiber shape are less difficult to uptake by the cell, but the longer silver nanowires, the nanowires, longer it is, 10 micron long, cause the lung inflammation with cytokine productions compared to the shorter size of a nanowires. Yeah, so different kind of the physical chemical properties of the particle will cause their different toxicity profile. So the main mechanisms and generally the researcher reported that it's because of an ion release from the nanoparticles, the ion that cause the productions of a reactive oxygen species. Yeah, so and this is the STEM tomography shows that we did this nanoparticle in the cell culture, and we found that the nanoparticle is not intact. It's not intact anymore, but it tends to dissolve and diffuse and form the ions. Yeah. So these ions may enhance the productions of a reactive oxygen species. So up to now, the exact mechanism underlying the nanotoxicity is still unknown, but generally it has been suggested that the overproduction of a reactive oxygen species may cause protein oxidations, chromosomal aberration, DNA damage, and also the cancer disease. Yeah, so I won't go deep into the mechanism. Yeah, if you have more questions or you would like to know more about the toxicology mechanism, then feel free to contact me after the presentations. So now the problem and the
For the
concern.
audience, you can
Yeah. Sorry.
yeah, the audience can post the question also. You don't have to wait after the whole session. You can post your question immediately at the comment section. So I see some people are already sending good jobs. Yes, and just so Dr. Leo knows, everybody is supporting you in this session. But if you have questions, do post also the same way as how you commented on the chat below, or you can go to Slido. Also, you can post it on slido.com as well for the questions. Sorry to interrupt. You can continue, Doctor.
Yeah. If any questions, feel free to drop your question in the comment. Then we will discuss about it. Take this as a discussion platform. Then, because we also would like to know how's your comment about the nanotechnology and like concern about the safety issues. Yeah. So for the concern issue related to nanotechnology, now the problem is the public are not well informed on the potential risk of a nano products. Yeah, so there's no specific regulation available yet, and wrong label on product. For example, if you have the product label with nano, yeah, and how you ensure that this product containing the nanoparticles. So that's the questions. Another one will be the no standard test method for human exposure measurement to nanomaterials. And as I mentioned before just now, the traditional method of measuring the micron-sized materials or the bulk metals cannot be used for the nanoparticles. So we need a nanometrology for the measurements. And also limited methodology to conduct risk assessment, life cycle to analyze the life cycle of the products. So I'm not sure whether any one of you heard about the asbestos. Yeah, asbestos. This is a report reported by the BBC News. So with a title asbestos warning on nanotubes. You can see the images on the left hand side. This is carbon nanotubes. Yeah, so the right hand side, this is the asbestos. If you compare with their morphology, do you think that they are similar? If yes, then you can type Y there. Yes. If no, then N. So you can see that they have the similar morphology. Yeah. And the report also mentions that the inhalation of an asbestos fiber caused a lung disease and cancer. Yeah, I think this incident happened in 18th century. Yeah. So now the question is whether the nanoparticle could be the asbestos in the 21st century. So we would like to discuss about this. Yeah, so the first reported asbestos death is reported in the 1906. So up to now 2020, the reported death still reported and is exceed 3,000 cases. So we can assume that this is a chronic disease. It won't happen immediately, but after few years later, so the case still happen. We know that the asbestos previously is It's used widely in the European country, but it's already banned because of the lung disease problem reported on the news. So that's why for the nanomaterials, it is very important to understand their life cycle behavior. For example, raw material productions. What happened to the worker? How about as a consumer, if we take the product that containing the nanoparticles, so what happened to us? And also the product end of life, either landfill, incinerator. So what happened to the worker? All these life cycles need to be understood, and some modification need to be done because the nanomaterials is behave so differently from their bulk analog. So I would like to show the bottle. Yeah, can show you the brand of it, but can you see the ingredient on it? When you see this bottle, I asked my friend bought it for like few years ago, but she not dare to use it because she don't like this product. And I asked her, do you know that this product contain microplastic or microbag? And she said she didn't know about this when she bought it. Then I asked her the next questions. If you know that, will you buy it? Then she answered me, if I know about this, then maybe I won't buy it. Yeah. Then now I believe that most of you know about the microplastic issues, yeah? So I would like to share with you all one video about microplastic microblast causing big problem to our oceans and also the environments. So have a look.
We hear a lot about pollution from single-use plastic items, like plastic straws and shopping bags, that are clogging marine habitats. Although these large pieces of plastic contribute the most to the overall mass of plastic polluting oceans, they count for a small share of the total number of plastic particles. That's because most of the plastic pieces in the oceans don't look like this. They're tiny particles that look like this, and where they're coming from might surprise you.
Modern fibers, alone or in blends with natural fibers, brought new innovations in cool, crisp, comfortable clothes.
Back in the 1940s, fabrics like nylon, acrylic, and rayon, all made from plastic, became really popular. These synthetic clothes were cheap to produce, comfortable to wear, and as more people have bought clothes for athletics and leisure, companies have been making more clothes out of plastic. By 2010, over half of all the fabric in our clothing was made from synthetic fibers. In the meantime, marine scientists noticed that habitats were being polluted with tiny pieces of plastic called microplastics. These are objects smaller than 5 millimeters and can be anything from tiny shards broken off larger items to microbeads developed for use in cosmetic products. Microplastics are found in marine habitats everywhere on Earth. Concentrations of microplastics have been found on coastal beaches in South Africa, the Great Lakes of North America, rivers in Britain, and at the bottom of an oceanic trench near Russia. Turns out, a large share of those microplastics are microfibers, tiny strands of plastic, and they're coming from our laundry. Looking at this fleece jacket up close, you can see that its fuzzy material is actually a fabric made from tiny strands of plastic woven together. When we wash a synthetic piece of clothing like this fleece, the fabric is pulled loose and tiny microfibers fall out. Scientists actually tested 3 types of synthetic clothing to see which type shed the most using a washing machine fitted with a special filter. They determined that acrylic shed the most microfibers, over 700,000 on the first wash alone. And even though fiber loss goes down after the first wash, the sheer number of people doing laundry adds up, making microfibers a huge contributor to the nearly 5 trillion pieces of microplastics that are floating around the world's oceans. In most dryers, there's a mesh screen to catch lint, but washing machines typically don't have a filter. So everything that falls off our clothes is flushed down the drain. And from there, microfibers might move through a sewage treatment plant, but the filters are often too large to stop them from passing through and flowing to a discharge point at a nearby marine habitat. Once they reach the ocean, microfibers are consumed by plankton and other filter feeders that eat debris falling to the sea floor. And then the plastic starts making its way up the food chain, passed on by predators feeding on organisms that have ingested microfibers. Eventually, it reaches us. Plastic enters human bodies when we eat seafood containing microfibers, like these, which scientists found in a piece of fish they bought at a seafood market. So, what can be done? Switching to other materials isn't feasible because synthetic clothes, they're cheap, a lot cheaper than making apparel with other fabrics. But what you can do is add a filter to your washing machine that would catch microfibers falling off when you do your laundry. Problem is, those are pretty expensive. So another solution is using filter bags that trap microfibers before they fall off into the wash when you do your laundry. But the most effective change of all would just be buying fewer synthetic clothes, or at least washing them less often. And what less often means, that's up to you.
So maybe you have better understanding that, our clothes also cause a pollution problem. Yeah, these microplastic made from polyester or polyacrylate, which not biodegradable and can build up in the environment. So as just like my friends, if she know about this content of microplastic, maybe she won't buy it. So as a smart consumer, we have a right to know about this. Yeah. So another issue, this is also related to the nanoparticles containing products. So bulk sealant chemicals, yeah. So this product has been recalled containing nitric oxide nanoparticles, and it causes edema. And if you go to a shopping center and go to the electrical sections, you might notice like washing machine in Samsung that contain the silver nanoparticles, silver ions. So the company claims that the silver can last for 10 years, over 3,000 wash processes. So NGO already called for past declarations of silver at the EPA level. And this skin cream containing the fullerene C60, and it claims that it have antioxidant properties, and it's quite costly though, $266 US. And then the researcher found that fullerene was found to be neurotoxic in fish. So NGO already called for strict regulation of the cosmetic. Yeah, so from the issues that I discussed just now, standardization is very important. Why it is so? It's because, for example, when you know centimeters, meters, it's because it's on the system of unit that easier for the global communications. Yeah, so for example, ISO 45001 on occupational health and safety, this is before and this is after. Yeah, and with this ISO standard documents, so the employer know how to take care of the safety of their worker at the workplace. Another one is like the ISO 9186 on graphical symbols. So, for example, to the ladies or the gents, no matter what clothes you are wearing, so because of the symbol that is standardized across the global country, then we know that, yeah, this is a ladies, this is a gent. So all these have been documented in the ISO 9186. For the nanotechnology as well, we need a standard organization for the standard document. Yeah. So the first one will be the ISO. Malaysia is a P member as the ISO committee. So in the ISO, there are 4 working groups. The first one is the terminology. For example, how you code it. I'm not sure whether Dr. John is here, and she's a committee in the working group as well. And the working group 2 is about the measurement and characterize it, how we measure the nanoparticle, how we characterize it. Working group have prepared the standard document for it. And working group 3, I think Mr. Kamaru is here, and me is in the working group 3. So we proofread the document for the health, safety, and environmental issues. And working group 4 is about the product specifications related to the product. So all these support for the regulations. And the ISO document, we have to pay to access the document. But another organization is called OECD, Organization for Economic Cooperation and Development. This is a working party working on the manufacture nanomaterials. Yeah, so OECD document you can access for free online. So if you type OECD nano safety, then all the document can be accessed for free. And here are the product with a nano claims nano label on it. For example, if you go to the Watsons Nano White, yeah, this product, nano sugar sweetener products, and also like Tala Silver is embedded with a nano silver and scientifically proven 99% bacterial eliminations. Yeah. Another product, for example, Nanoman, they use the word Nanoman and they claim that and the product can be used for the car polishing for the better applications. So all these products contain nano wood in it. So now the question is, are they really have a nano materials in the products? So that's the questions. So the product regulations is very important. That's how we need to do the safety testing for each product in the market. Yeah, so the risk assessment is to identify the risk, analyze the risk, and evaluate the risk. If a threat has been identified, then action need to be taken before the product pass the regulatory objective. So if it's failed to pass the regulatory objective, so this product need to be removed. If it pass and without causing any adverse effect for the consumer, then it can be sales in the market. So this is called the good manufacturing practice. Yeah. So I would like to share about this is an online version of the Law of Malaysia Consumer Protection Act. Yeah, in section 19, it called that the supplier of any good or services is required to adopt the standard of safety as expected by consumer. Section 20, no person may supply or advertise any good or services that do not comply with the safety standard. Another one, for example, the cosmetic that we purchase from the supermarket, these have to follow the guideline for control of cosmetic product in Malaysia, and this is under the monitoring of National Pharmaceutical Regulatory Agency, Ministry of Health. So a product cannot be, Section 6 claim that a product cannot be marketed if it is not safe. Yeah, Section 7.1 provide customer with adequate info as to the safety of an ingredient. For example, the product has been done the physical chemical test and also the toxicity study. So here show the example of the common technical safety data. For example, if you would like to commercialize cosmetic products, so you may send to serum for the acute dermal toxicity test, skin sensitization test, and skin irritation and corrosion test. So serum will give you a test report. All these has been documented in the OECD standard documents. For example, the environmental toxicity data, toxicity to the plant, fish, microorganism, bioaccumulation in aquatic, all this has been documented in the OECD documents. So this is a common technical safety data and also used for the product that containing the nanoparticles. However, we need a new technical data for nanomaterials because they behave so different from their bulk metals. So all this is the testing to characterize the nanomaterials. For example, the particle size distributions, their surface areas, zeta potentials, porosity, all this has been documented in the ISO document. How are you going to characterize it? All this is documented here. Yeah. So if you need the document, then you may contact the Standard Malaysia to get for it. Another one is like my friend asked me, for example, I have a product that containing the nanomaterials. Yeah, I would like to get the certificate. So so there's a nano verified programs under the Nano Malaysia's. It's a voluntary nanotechnology certification program, jointly with a serum and also the Standard Malaysia advisory. So, and this program is to certify processes and product with a claim of a nanometers. As I mentioned just now, in the range between 1 to 100 nanometers. Yeah, so Malaysia government also put effort, for example, thanks to the National Nanotechnology Center and NC under MOSTI. So, this is Mr. Kamaru, I hope he's here today with us. So this is our colleague from Korea. This is me. So we attended the ASEAN Nano Forum meetings in 2017. So the expert from all over ASEAN country was there to discuss the nanotechnology and the safety aspect. I think this is a very good platform for all the researchers, the expert group, the regulatory body, and even the industry, the public sit together to understand about the nanotechnology and their safety aspect. Another one is this is a nano safety course organized by the National Nanotechnology Center NNC and also the United Nations Institute for Training and Research UNITA. Yeah, so the purpose is to provide an insight on the safety of a nanotechnology. Yeah, it's quite a few number of people attended. Yeah, and we share about we learn about the nano safety during the courses. So thanks to the NNC also organized quite a few of the nano safety workshops for us to discuss about the regulatory and standard of nano materials. Yeah, and recently the mostly also organized the nanotechnology workshop, I think last month. Yeah. So thanks for Mr. Kamaru for sharing all these images with me that I can share to the public. So then my friend asked me the next questions. Yeah, how do I know that the product is safe to use? Or yeah, for example, if I show you this product, it shows that there's a halal logo here, and the chocolate with ISO halal logo here as well. So with all this label, we know that yeah, the product is certified by the certified body. Yeah, with a logo halal, and you can even ask the certificate from them, from the manufacturer. And another one is the cert. Yeah, I got several products, for example, and the cosmetic claim that yeah, this product contains the organic compound. So you also written here is certified by the cert, and this product as well. This product certified by the EcoCert Green Light. So this is EcoCert is an organic certification organization certified the food product, cosmetic, detergent, or perfume textile. And recently, yeah, my friend introduced a supplement to me. Yeah, and then the first question I asked her is, did your product get the certifications from the certified body? Yeah, and she showed me that yeah, this product has been approved by the standardizing bodies such as FDA, Food and Drug Authority, National Sanitation Foundation (NSF), and also United States Pharmacopoeia (USP), and also the Good Manufacturing Practice. So all these certification will enhance the confidence for us as a consumer. I think the certification of product is very important for the risk assessment before this product can be commercialized in the market. Yeah, so there are two monitoring authorities for different kind of a product. For example, the pharmaceuticals, cosmetic, food additive, veterinary drug, medical device. This is all monitored under National Pharmaceutical Regulatory Agency (NPRA). Yeah. Besides that, the industrial chemical, pesticide, feed additive, biotech, non-pharmaceuticals is under the standard Malaysians. Yeah. So I would like to show you this video to explain about the consumer right. we have a right to ask if the product containing any dangerous chemicals. For example, the case just now, if you are unsure about like whether this product containing any chemicals, you read the ingredients. If you still don't understand, then you can contact, like for example, there is an email address or the contact number. You can contact the manufacturer and ask the detail about this, because this is your right as a consumer. Yeah. So, and that's all from my presentation. I would like to end this presentation with a quote from the Superman movie. With great power comes great responsibility. As we know that nanomaterials can be used in different kind of applications, as I mentioned just now. But it is also our responsibility to make sure the product is safe before it can commercialize in the market. So the risk assessment is very important. And thank you for your attention. Sean, back to you.
Thank you, Dr. Leo. Again, if you have any questions, do post it on your comment section and let us know what you have as a question for Dr. Leo. And at the same time, if you have listened for the whole session and you felt that you have benefited a lot from today's session, do give us some good feedback at the slido.com. So just type in sli.depo.com and the event code is SafeNano. Do let us know, show us your support by saying that there is some beneficial value being shared over this session. Now, Dr. Leo, we have questions from the audience. Let me just flash it out on the screen. The first question came from Tan Yong Chi. And the question is, I saw products using arginine, I think that's silver, right? Arginine, as nanoparticles for eye drops to treat cataract in canine eyes. Can you please tell more about this? So let us know the safety concerns behind this material itself.
Yeah, thank you for your questions, Dan. Silver, as I showed in the PowerPoint just now, silver is a commonly used nanoparticles among all these nanomaterials. Is because of an excellent antibacterial effect. During SARS, if you're aware that people also spray the silver spray, that they believe that it can kill the bacterials. Yeah, so for the cataract in canine eyes, I'm not sure about this, but I believe it's also because of the antibacterial effect. Yeah.
Understood. So maybe for Tan, you can Google out, find out what's the safety precaution. And as Dr. Leo said, you are a consumer. You have the right to find out whether there are dangerous implications of this material to your loved ones and to your pet as well. The next question is it arginine, or is it, correct me if I'm wrong, Ag ions?
Silver,
is an
you
ion?
can mention is silver. Yeah.
Silver, okay then, thank you so much.
Yeah,
Is silver
ion.
an ion? If yes, then it's probably for antimicrobial purposes. So when silver reaches nano level, is it an ion? Maybe you want to explain on that?
Oh, yeah, and silver is an element, yeah, but it can be in different size. For example, it can be a metal block, silver metal block. It can be the silver particle in micron size. It can be smaller silver nanoparticles, as I mentioned, 1 to 100 nanometers. But why silver nanoparticle is so reactive and it can be dissolved and become the silver ions. Silver ion is Ag plus. Yeah, when it dissolve, it form the ions. So one silver, it can be formed in the different size and in the different form. Did I answer the questions?
So depend.
Yeah.
Yeah, it can be in any form.
Yeah, I saw that it's antimicrobial purpose. Yeah, we also done the study about this. Actually, there are two mechanisms if you're interested to know more. For example, yeah, it's a silver that dissolve form the silver ions. So these silver ions can interact with the bacterial membrane, then cause the antibacterial effect. Another one is the silver ions interact with a cell membrane, then the silver go inside the cell and dissolve further, so they are Trojan effect. There are two mechanisms that discussed in the science paper. Yep.
Oh, all right. Okay. So we want the silver in ion form to have the antimicrobial effect. All right, got it.
Right.
The next question came from Joey Ong. It's a long question. Hi, Dr. Liu. I came across some natural marble stone. Maybe I won't mention the brand. Used for tabletops, vanity top that are encountering some etching or staining issues when I have red wine, coffee, acidic drinks poured onto it. Is it possible that nanotech can do something about it? Or is there any finding on this matter just as of now? Thank you. So
Thank you,
nano
Joy,
as a
for
cleaning
your
material.
thank you, Joey, for your questions. As shown in my presentation, there are different kind of application using nanoparticles. Why? It's because of nanoparticle is so reactive. It can be it have higher activity compared to their bulk metals. So why people tend to use nanoparticle instead of a micron size or the larger size of the particles? Because of our surface area and their surface property easy to tune. Yeah, I can make this PET particle hydrophobic, hydrophilic, light water or dislike water, or I even can functionalize with different group to make them, like for example, and for different kind of specific applications. Yeah, so why people prefer to use nanoparticle because of a surface area, easy to tune the surface property, and then for different kind of applications, then we can design the particle for that specific applications. Yeah. I hope I answered your questions.
I think it does. Don't worry. We have a lot of questions coming in, and I think a lot of them were thanking you for sharing such a great presentation for today's topic. And I think nanoparticle is something that we always know, we always heard about it, but we're always wondering what is the regulation behind it. And I think it revolves back to this very fundamental question. Is nanoparticle being widely used in food industry in Malaysia? Is it safe? And I think this is also the main topic of your presentation today. Is it safe? And do the manufacturer declare if the food have nanoparticle in it? And over to you, Dr. Liu.
Yeah, I showed the nano sugar just now. It because if the product really contain the sugar in the nano side, it's easier for the sugar to dissolve. Yeah, because of the to a surface area to volume ratio, the easier for the nanoparticle to dissolve. But currently, there's no regulation yet for the nanotechnology. Yeah, so it is very important for the manufacturer. For example, if the product really contain the nanoparticles, maybe in the ingredient that should label it. Yeah, so for a consumer, we have a right to know about, this product really contain nanoparticles, and I have a right to choose whether I should buy it or no. It just like the nanoplastic, the microplastic that I showed just now. Yeah, so do the manufacturer declare if the product have nanoparticle in it? And we encourage the manufacturer to declare and do the risk assessment, as I showed the safety testing with the relevant agency, and also maybe can send the product for the nano verified program under Nano Malaysia. Yeah, there are several programs organized by our Malaysia government.
Right, good to know. And I think this is the first time many of us heard about Nano Verify. So if you have doubts about the things that you consume or the things that you're putting into your body or on your face containing nano material, maybe you can just check it out. Nano Verify program in Malaysia, and that's a program that encourages awareness, not only what you are using, but also what you are also knowing about the nano material that is around us. And we have one more question, which is from Su Yin. Hi, Dr. Nathan Leo. Very nice presentation. Can we use silver nano to protect us from COVID-19 pandemic? And I think that's a bit of a relevance to the situation that we're facing now. It's nano silver or any nano material going to protect us from COVID.
Yeah, if you type nano silver COVID-19 pandemic, then you will get the news about it. Because I typed last few days, there was a news about it though. Yeah, because silver nano is a good antibacterial and also the antiviral. Yeah, that's how it can be used, but maybe all these have to go through the risk assessment process. As I mentioned, any products that commercialize in the market is to go through the risk assessment to ensure it is safe to use for a consumer. And then just for like the COVID-19 vaccine, yeah, everyone rushed to get the vaccine, right? But it still have to go through the proper protocol for the trial, 3 stages trial before it can be commercialized, can be used by the human. I hope that the product that containing the nanoparticles will go through the same safety risk assessment as well. So to ensure the safety for the consumer like us and also the environment. Yeah.
So as smart consumer, question the person that offers this solution whether it's done the proper safety assessment, because in the end of the day, we don't want to end up killing the COVID and also killing ourselves at the same time. And I think it comes back to the question about safety. Is the effect to our body of nanomaterial high in toxicity? And I think this comes back to the question, it could be toxic to virus, but is it toxic for us using it as well? Maybe you can answer that, Dr. Leo.
Yeah, in the presentation, yeah, I show that there are different kind of physical chemical properties. For example, different size, different shape, even the concentrations. I did mention the concentrations. Yeah, the functional group, different surface coating will change the toxicity profile. Yeah, so that's why if a product then containing a nanoparticle have to send for the risk assessment testing to ensure it is safe. If the nanoparticles is in, like for example, low concentration, it can be removed by our body system, but it is too high that our cell cannot handle it anymore. Yeah, so this might be overloaded in our body, that it might cause like the cancer effect, the cardiovascular disease. Yeah, so there are a lot of articles that you can read. If you type Google the toxicity of a nano, then you will get better idea about this. But yes, if the concentration is high enough, it will cause the negative impact into our human body. Yeah.
And I think it's also the same question from Omar regarding milk, carbon source such as milk to produce quantum dots. Is it possible that materials will produce ions that are toxic to cell? And I think it falls back to the question of having risk assessment, finding out what is the right level of the nanomaterial so that it doesn't cause toxicity to us and also to any cell or any cows that produces it. But there's another interesting question from Iktifa. We're talking about toxicity to us as human beings, but what is the impact to the environment? Now, his question is, nanomaterial takes a long time to be degraded and might harm the environment. Maybe we are focusing so much about the impact of on human beings. What is the impact of nanomaterial on the environment?
Yeah, I showed a video on the microplastic. Yeah, it can be nanoplastic though. If the size is smaller enough, it can be digested into the nano size. It's sent with nano materials. Yeah. So for example, if there are a lot of consumer product containing the nanomaterials, yeah, if it is not filtered properly, these nanomaterials may be uptake by the fish, the ecosystem in the oceans. You know? So this nanomaterial is just similar case as the nanoplastic, microplastic cases. That's the reason why I shared the video just now. Yeah.
Okay. And we would have, that's all for the questions from the audience. I do have one more question, I think, and that's a personal question from me. If we want to find out more about, and I think as we open this session more and more, there'll always be question, is this nano product A and this nano product B is safe, things like that. I think the question would be endless. What would be your recommendation to all of us, the audience? Because nanomaterial will be the future. It will be everywhere, whether we like it or not, whether we're aware of it or not. nanomaterial is here to stay. What can we do as responsible consumer? And I hope that could be a closing message, a call to action to all of us, people living in the modern era. What would be the word of advice for us as consumer to avoid the effects of nanomaterial in our future?
Yeah, as I mentioned just now, nanomaterials used in different kind of application because of the excellent properties, high surface area, more reactive compared to the bulk analog. So yeah, it can be commonly used in in the different kind of application due to extraordinary applications. Yeah, but as a consumer, we have a right to know about this. For example, if a manufacturer produces a product containing nanoparticles, maybe they can write as an ingredients. Yeah, every product have an ingredients though. So maybe they can write that. Then the consumer we know about this, so we have a right to choose whether we want or not to use it. Yeah, and the regulatory body maybe they can do some enforcement. Yeah, so there's like the effort, the contribution from all party, the manufacturer, the consumer, and even the certified body, the regulatory, all of us, and have like work hand in hand in protecting our environment and also our next generations. Yeah, so I hope this webinar will help you to have a better understanding about the nanomaterials and also the safety concern. If you have any questions, feel free to email me or contact me and we can discuss further about this topic. Thank you very much for spending such a wonderful Sunday. Yeah,
All right.
thank you.
Thank you so much, Dr. Leo. It's such a pleasant time having you here. And again, for those of you who are just new to the channel, Science Cafe is something that we have every month. So do stay tuned to our Facebook page. Do search us out, YSN ASM Science Cafe page, or in this particular one is Science Cafe KL page. Due to the COVID situation, we are unable to have this session in Bukit Bintang, but this is just as good. I think Dr. Leo also loved the audience today. I think a lot of great questions coming from the audience, and I really appreciate the support that is given by the audience and also the support given by Dr. Leo. So we have not announced who is our next speaker for the October. Do stay tuned to YSN ASM Facebook page or YSN ASN Science Cafe Facebook page, or if you like this channel in particular, just search us out Science Cafe KL Facebook page. With that, thank you so much. Thank you so much, Dr. Leo, for your time, and have a pleasant evening. Everybody, have a great day ahead. Thank you so much.
Thank you, Sean. Thank you all.
Bye, everyone.